Good afternoon, students. We'll continue with our chapter 3. So, the last topic which we had completed was inverted page tables. Now, we'll be going with inverted page after inverted page tables, page replacement algorithms. So, for replacing the page, there are certain algorithms which are being performed, and for that, first one is optimal algorithm, not recently used algorithm, first in, first out, FIFO algorithm, second chance algorithm, clock algorithm, least recently used algorithm, working set algorithm, and WS clock algorithm. So first we'll be going with the before page replacement. I'll be explaining you optimal page replacement algorithm. So first one is optimal. To compare all the page replacement algorithm, this algorithm has the lowest page fault rate. Page fault is there is no error, lowest error rate is in optimal algorithm. As well as this algorithm replaces the page which will not be used for longest period of time. So the pages which are not used for longer period of time, those pages will be replaced by this algorithm. As well as this delays the unavoidable page faults as much as possible. So rather than keeping it for more time and delaying in the problem, what we can do is they can be either removed directly to decrease the amount of page faults, as algorithm replace the page on the basis of future use of page. So future use, if it is there, then it will keep. If it is not of future use, it will remove. So it is impossible to implement. Future usage is not there or not, if it is not possible, so implementation also becomes somewhere difficult. The optimal algorithm is unrealizable because it is impossible to determine the number of instructions that will be executed in the future. Yes, in the future, how many algorithms for it, optimal algorithm will be implemented or not, they cannot predict. So that is the reason it is somewhere unrealizable. Then, since the policy is this, that if it is not used for a longer period of time, the reference also becomes difficult. So next is not recently used algorithm. At page fault, system inspects the page. So checking of the pages is done at the page fault level. Categories of pages based on current values of their R and M bits, that is class 0 not reference not modified, class 1 not reference but modified, class 2 referenced not modified, and class 3 reference and modified. So these are done, these classes are being given as a inspection page number for the page faults to not occur, or if page faulting is occurring, it will give you an inspection which is done in the not recently used algorithm. Next is first in first out. First in first out is a algorithm. Another low overhead paging algorithm is first in first out algorithm. To illustrate how this works, consider a supermarket that has enough shelves to display exact k different products. One day, some company introduces a new convenience food, instant freeze dried and organic yogurt that can be reconstituted in a microwave oven. It is an immediate success, so our finite supermarket has to get rid of one old product in order to stock it. So this is an example which has been given for first in first out algorithm, that a supermarket has a n number of products and it's a big with n number of shelves into it. But one day a new company comes with a new product which is a yogurt, that is curd, and that yogurt can be used for a long period of time with just you can transmit it from a fridge to a oven, and then also its consistency does not change. And for that, the supermarket, what it does, because of this new product, the older products they want to remove it as a old stock. So one possibility is to find the product that the supermarket has been stocking the longest and get rid it in the grounds that one is interested any more. So what they will do, they will consider two things, that is one, how many products are there and how many years they are there in the supermarket, for how many years they are just taking over the market. and to get rid of it on the grounds that no one is interested anymore, and they can give it a reason that no one is been using this product, so we need to stop it. In effect, the supermarket maintains a linked list of all the products it currently sells in order they were introduced. It will check the linked list that how many such products are there which are a competition to this product, but still people are not purchasing it. As a page replacement algorithm, the same idea is applicable. The operating system maintains a list of pages currently in memory, the most recently arrival at the tail and the least recently arrival at the head. On a page fault, the page at head is removed and the new page is added to the tail of the list. When applied to stores, FIFO might remove grains, but it might also remove flour, salt or butter. When applied to computers, the same problem arises with the oldest page may be still be useful. For this reason, FIFO in its pure form is rarely used. So FIFO is like the recently used pages will be put in the tail, that is at the back. The currently used pages will be put in the head, that is at the first, so that what will happen is it will maintain a proper arrangement so that people could use those recently used pages for a longer period of time, and that is the reason it can be called it's pure, and that is the reason somewhere it is rarely used. So the next is second chance algorithm. When we talk about second chance, after FIFO it was second chance algorithm. So second chance algorithm is like the FIFO algorithm is basic algorithm of second chance replacement algorithm. Somewhere a basic structure of FIFO is being followed by second chance algorithm also. After selecting page for replacement, if its inspect, its reference bit is checked. If reference bit is 0, old or unused page, then the page is replaced. That is, if reference number while inspection of page faulting is 0, then it will be termed as old or unused page. If not, if the reference bit is 1 while inspection, a second chance is given to the page and then proceeded on to select the next FIFO page. Then it is moved on further for processing, that is for first in first out. Then because of this page that got a second chance will not be replaced until all the other pages have been replaced. All the other pages need to replace because of this. So a second chance is being given. And in addition, if a page is used often enough to keep its reference bit, if a page is kept for its reference bit to be 1 or to be 0, then it will be never be replaced, because if its reference bit does not change, it will never be replaced. After second chance algorithm, that is clock algorithm. So clock algorithm works on the clock framing, that is page frames on a circular list. There is a clock direction which is being done. The clock hand points to the oldest page. Clock hand points will be on the oldest page. The oldest page is C. And after the occurrence of page fault, once page fault occurs, the page being pointed to by the hand is checked. So page being pointed by the hand, that is the arrow, is being checked properly. If its reference number is 0, evict the page. Evict the page is replaced and a new page is inserted into the clock. Instead of this page, if the reference number comes 0 while checking, it will be replaced by some another page here. If not, after insertion of new page, the hand is advanced one position. If reference bit is and advances, it will move further to B, that is the further position. If reference bit is 1, it is cleared that the hand is advanced to the next page. It will directly move to the next page. If the reference number is 1, there is no problem. Next is simulating LRU in software, that is LRU stands for least recently used. When you talk about least recently used, the time of page is Last use is associated with each page. The last use or last updated page is always done in least recently used page replacement algorithm. LRU is good approximation to the optimal algorithm. For optimal algorithm, LRU can be used as an option. This algorithm looks backward in time. It will go backward in time, and to check the optimal replacement algorithm looks forward in time. It predicts for the future, it predicts for the backward direction, that is the past. This policy suggests that replace a page whose last usage is farthest from the current time. So farthest means it's large away, and that is the reason it should be checked with the current time and removed or replaced. This algorithm can be implemented with some hardware support. With hardware usage, you can use this least recently used algorithm, and is considered to be a good solution for page replacement. So it can be a good example or good solution for page replacement algorithm. Next is working set algorithm. Working set algorithm is again depending on the working graph. The pages are being in function and the working time it requires. On that they have drawn a reference graph of with respect to time and functioning. So working set algorithm works in a programming culture like this, that is the time last use, page reference during this tick, page not referenced during this tick. So all these information about one page, all these information are referenced, and the reference bit is also being given beside that, so that the working clock could work, algorithm could work on current instance of time. Then WS clock algorithm, shift R bit time last use, then shift to next bit. All such things, the arrow shows the current working page, then the page is shift. Give an example of what happens when R is equal to 1. When if it is reference bit is 1, then what will happen? Reference bit is also given beside it. Then the time of last use, whatever is there, is also given in WS clock algorithm. The solution, new page once enters, then it moves to next page. So give an example when R is 0. So if R is 0, it will be replaced by another page here. So summary of page replacement algorithm, we heard about optimal algorithm, which is not implemented but useful as a benchmark. NRU is not recently used, very crude approximation of LRU. It is similar to LRU. FIFO is might through out important pages. To check the actual importance of the pages, FIFO is being used. Second chance is big improvement over FIFO. So updation of FIFO is second chance algorithm. Clock is real time changes. LRU is excellent but difficult to implement exactly. Least recently used, can be a problem but can be exactly implemented. NFU, that is not frequently used, fairly crude approximation to LRU and updation. Then aging, working set and WS clock. So these are the algorithm, and they have a proper summary of all the page replacement algorithms here. Next is local versus global allocation policy. Local means here local values, and the global values which are being used by the process is being shown here. Local versus global paging in a graphical format. Then separate instruction and data spaces. If you have a separate instruction, and for that instruction you have a separate data set, is being shown with a diagrammatic format. One address space, separate I and D spaces, that is instruction as well as data separately. Shared pages over a process table. One process table which has shared different pages, that is two processes sharing the same program, that is called as multi-programming. Shared libraries is values which are stored in form of processes, that can be termed as shared libraries. Page fault handling, the hardware traps to kernel, saving program counter on stock. Assembly code routine started to save general registers and the volatile info. System discovers page fault has occurred, tries to discover which virtual page needed. Once virtual page caused fault is known, system checks to see if address valid and the protection consistent with. If frame selected dirty, the page is scheduled to transfer to disk. Context switch takes place, suspending fault processes. So page fault handling, how it is done, is been given here. So hardware traps the kernel, hardware asks the kernel, saving the program on stack, that is on a temporary memory. But assembly code routine already started to save general registers, normal registers, and other volatile information of that particular program. System discovers page fault. Once pages occur, the page fault is discovered by system, and to try to discover this virtual page is needed or not. They will try to understand that whether this page is required to understand or not, that if it is needed or not. Once virtual addresses cause fault, virtual addresses are temporary, and if have a problem, then system checks if the address is valid, their address space is valid or not, and the protection consistent with them is also correct or not. Then the page selected for page fault is dirty, then the page is scheduled to transfer to disk. From the stack it is transferred to the disk. Context switch takes place, suspending faulting process. Suspending means removing it from the page faulting process and applying it onto the disk. As soon as frame is clean, operating system looks up disk's address where needed page is and schedules disk operation to bring it. Now once all the problem is solved, what it will do, it will search for that page from the disk and reschedule it on a new address and give the operations which it requires. When disk interrupt indicates page has been arrived, disk interrupt will tell the system that yes, page is arrived, tables updated to reflect position. Page tables need to be reflected to show that table position, and frame marked as being normal state. Now once it has completed all the problems and it is clean, it will be marked as normal state. So faulting instruction backed up to state it had when it began, and the program counter it reset. So program counter will be increased by 1 as the program is resetted. So this is the routine reload registers and other state information. Returns to user space to continue execution. So other process will be executed which is being replaced. So we'll stop here for this particular topic. We'll continue in the next lecture.